Okay, so I'm going to try something here. I'm going to just try a few different derivatives by first principles. So let's just kind of think of some. So let's say if f of x was, say, I don't know, 3x squared, yes, we know that f dashed of x would end up as 6x. So that's something we can basically try. You can make them up yourself. You know what the answer is going to be. So just basically try it and see what it comes out to be. So we'll set up our f dashed of x. Well, that's going to be equal to the limit as h tends to 0. And then what we'll do is it will be 3 lots of x plus h squared subtract 3 lots of x squared all over h. Okay, we'll keep going with this. So this is going to give me 3 brackets. It's going to give me x squared plus 2 hx plus h squared subtract 3x squared all over h. Okay, keep tidying. Write my limit of h tends towards 0 every single time the same. So we've got 3x squared plus 6hx plus 3h squared subtract 3x squared all over h. We know that this is going to cancel out. So those cancel out there. Limit as h tends to 0. We're going to have, and also I'm going to divide every single thing here by h. So I'm going to be left with 6x, oh, it's looking good, plus 3h. Okay, now as h tends to 0, 3h tends to 0. So we have f dashed of x would be equal to just 6x. Okay, so it worked. Let's just try another one. I don't know, we could try something else. Let's say f of x is something we haven't done already. Let's say it's x cubed plus, I don't know, 5x. So let's apply the same principle to it. It's going to be the limit as h tends towards 0 of, let's do that function, but with x plus h subbed in as x. So it's going to be x plus h cubed plus 5 of x plus h, and then we're going to take away kind of all of this function, but with x substituted into it. So it's going to be x cubed plus 5x, all subtracted here over h. I'm not seeing an exam question like this yet, but you never know. Okay, limit as h tends towards 0. So let's all figure all this out. This is going to give me x squared plus 2hx plus h squared plus 5x plus 5h subtract x cubed subtract 5x all over h. Okay, let's do some tidying up. Well, we've got already I've made a mistake here, haven't I? Blooming heck. So this should be a 3. Come on. So if this is a 3, this is going to expand out a little bit better. So let me have another go at this properly. So this section here is going to be x cubed plus 3x squared h plus 3x h squared plus h cubed. All right, let's see if anything will actually cancel out here. Well, we've got x cubed subtract x x cubed. We've got a 5x subtract a 5x. So that's the problem with making these things up on top of your head. Let's see if we can actually get all this working. Now, everything that I've got left has got a factor of h in it. So let's just basically go for this. We've got 3x squared. Well, let's divide by h. So let's kind of get rid of one of these h factors in here. So we've got 3x squared. We're going to have plus 3xh plus h squared plus 5, and then everything else is done. Now, any term that's still got a h left in it is going to end up being cancelled out as h tends towards 0. So we can say as h tends towards 0, 3xh tends towards 0, and h squared tends towards 0. So our derivative of our function would be whatever's left over, which is 3x squared plus 5. Okay, now did that match up with what we wanted it to happen up here? So we know that if we just apply the differentiation algorithm to this, we would turn this into x cubed would go to 3x squared, and 5x just plus 5. So actually, that's worked.